Welcome back to college trigonometry, college algebra. I'm sorry because I have two classes. I'm sorry. Welcome back to college algebra. My name is Professor Nguyen, and let's continue with our new lecture today. So I don't know. Before I start a new lecture, I want to ask you. I don't know if you guys remember one very important concept you learn in intermediate algebra. It is how to solve linear inequality. What is linear inequality? Linear inequality is it's kind of like the equation, but instead of using the equal sign, we use greater than, less than, greater than or equal, or less than or equal. And when you solve linear inequality, the solution is not just one or two solutions. The solution it has many solutions, and because it has many solutions, we have to express it using interval notation. We can express it using the algebraic method, or we can also express it using a graphical line. Okay, but that is for when you solve linear inequality. For the lecture today, I want to talk about something new. I want you to learn how to solve nonlinear inequality. When I say nonlinear inequality, I mean something that is not linear. And something that is not linear, we already learned in the past, it was quadratic, right? Quadratic is not linear. And quadratic is second degree polynomial. Okay, so if you have a higher degree than the first degree, then I can consider as nonlinear inequality. For example, I can say third degree polynomial inequality or fourth degree polynomial inequality. It is a fourth degree, then instead of using the equal sign, I replace that with greater and less than, and I want to solve for the solution. And the solution again for nonlinear inequality, the solution is not just 1, 2, or 3 points, but the solution it contains many values. Okay, and graphically, you see that polynomial. When you graph polynomial, polynomial is intersect the x-axis at many points. And because it intersects axes at many points, so it contains many values. Well, it depends on the highest degree of the polynomial. We know how many intersection points, and because we know how many intersection points, we know what part of the graph of polynomial above the x-axis and what part below the x-axis. When we know this, where it's above and below the x-axis, we can get a solution of nonlinear inequality. Okay, so today we want to talk about nonlinear inequality, and we want to solve nonlinear inequality. Okay. Okay. And another type of nonlinear inequality, it is a rational inequality, because rational equation is when you solve rational when you solve rational linear inequality, it's kind of the same as you solve polynomial inequality. You also use the same method. The solution is also it's not just one or two solutions, but the solution is contain many solutions. Sometimes it has infinite many solutions also. Okay, so I'm going to talk about polynomial inequality first. Then after polynomial inequality, I want to talk about rational inequality. And both of them is considered as nonlinear inequality. Okay. So, in the first part, I want to talk about polynomial inequality. Okay. And the simple polynomial inequality, it is a quadratic inequality. Okay. And we have two different methods to solve quadratic inequality, as well as to solve for polynomial inequality. The first method is we use the graph of quadratic function. So first of all, a graphical method. When you use graphical method, you graph the function, the quadratic, and you see what part of the graph above the x-axis and what part of the graph below the x-axis. Then you can get the solution for that inequality. For example, let me see. I can give you something in the quadratic form. How about this? 2x squared. Okay. Example, I have 2x squared minus 3x minus 5 minus 3x minus 5. Okay. And I want to solve it when it's greater than 0. Okay. So I know that this is an inequality because it's greater than sign. Okay. So because this is graphical method, so I want to graph this. And in order to graph it fast, you just need to find the x and y, the x-intercept of this quadratic expression. So in order to find the x-intercept, I want to factor this. Let's see, I can factor this to give you 2x, and this is x, right? And this is give you -5, and this is give you 1, right? Greater than 0. Then you find two x-intercept point on the x-axis, okay, which is give you what? -1, right? -1, and 5/2, which is 5/2. There's 3 here. 5/2 is the 2.5, so this is 5/2. Okay, so we have two x-intercept point. Okay, and we know that the a value is positive, so we know this open up. So we know our graph is something like this. Okay, we doesn't have to be perfect, but we need to know how it looks. Okay, we know it's open up, and you see that if you investigate the graph, you see that the bottom part over here is below the x-axis. So the part I color in red is below the x-axis. Okay, and the two parts I color in blue, okay, is above the x-axis. So if it's above the x-axis, I put the plus sign. Okay, and if below the x-axis, I put the minus sign. Okay. The question is that, how do I know that we want it above the x-axis or below the x-axis? Of course, you have to look at the original sign. Okay? For original sign, it is a positive sign because it's greater than 0. So we know that we want to pick the positive part. Okay? We don't want to pick the red part. We want to pick the blue part. Okay? So the final answer, okay, by look at my graph, my final answer will be, because this is above the x-axis greater than 0, I've got to put a plus sign here, and this keep going up, right? And it keep going up, so the answer, write it in interval notation, will be -infinity to -1, parenthesis, because there's no equal sign here, union with, okay, union with what? Union with 2 positive infinity. Again, we cannot use bracket because there's no equal sign here, and you see that this is keep going up, right? So this, we look at the x value, so it will be from 5/2, it's 5/2, sorry, Okay, phi over 2 to positive infinity, and this is from negative infinity to negative 1. Some students put negative 1 to negative infinity. It doesn't make sense, okay? You have to put from the left to right. Negative infinity to negative 1. So this is my interval notation answer for this inequality. So this is the solution. Okay? So that is the graphical method when you solve quadratic inequality. Okay? Or in this case, it's second degree polynomial inequality. The second method, it is to use the table, the side table. Side table. Okay? The second method to solve inequality is to use the side table. What is the side table? And how I'm going to set up the side table? Okay? In order to set up the side table, okay, you draw the number line, and on that number line, you mark negative infinity to positive infinity. Okay, on that number line, I mark two x-intercept value. In this case, is negative 1. Okay, negative 1 and phi over 2. So phi over 2 must be on the right hand side of negative 1. Okay. Let me check one more time if I factor the right, 2x squared, right, 2x minus 3x. Yes, okay. So you see that after I mark 2x value on my number line, it's divide my number line into 3 parts, 3 intervals. So we need to check what interval, what sign, positive or negative, will be in each interval here. Okay, so how I'm going to check it? Let's check this interval, between negative infinity and negative 1. I will pick the value between negative infinity and negative 1. For example, I pick negative 2. Okay, I pick negative 2. Okay. And over here I pick 0, because it's 0 between negative 1 and phi over 2. And over here I pick 3, for example. Okay. I put negative 2 in here. I put in 2 into the x. Okay. So I put 2. Okay. I replace x with negative 2. So negative 2 squared minus 3. I replace x with negative 2. So 3 times negative 2 minus 5. Okay. And I calculate them out. Let's say it gives you positive and negative answer. Okay. So it gives you 4. 2 and 8, right? This is give you 6 minus 5. So 14 minus 5 is 9 positive, right? 9 positive. And because 9 positive, I put over here is a plus sign. Okay. Same thing, I put 0 in. So I have 2, 0 squared, minus 3, 0, minus 5. Give you what? Negative 5. Negative, so I put negative sign here. Okay. Same thing, I put 3 in, so I have 2, 3 squared, minus 3, 3, minus 5, give you 6, 18, right, minus 9, minus 5, 4, positive, so I put positive here. And the original answer, we want positive, so my answer will be this part. We got a positive sign. Because it's positive. So you see that I can get my final solution will be negative infinity to negative 1 union. Okay. Phi over 2 infinity. So you see that it's the same as this. It's the same as that. Okay. It's the same as this. So then again, there's 2 methods to solve polynomial inequality. Graphical method and side table. Okay. But that is when you have a simple polynomial, a second degree polynomial. It's considered as the simple one. What if I have a very high degree polynomial? For example, I have like 10 degree. I have 6 degree, 8 degree. What could I do? In that case, graphing will be pretty hard. I mean, I don't say that we couldn't do it. Because you have calculator, you can graph it, yes. Okay. But on the test, if I ask you, I give you the high degree polynomial and I ask you to solve for that inequality, you have to use sign table. Okay, you have to use sign table. You shouldn't graph because I don't recommend it. I mean, you can put into calculator, you graph and you see what part is greater, what part is above the x-axis, what part is below the x-axis. But when I asked you to do on a test, I want you to use a sign table. Okay. For example, what if I give you something like this? Okay. For example, so inequality. Okay. What if I give you something like this? How about something? How about like this? X to the 4. Okay, see that? High degree is greater than second degree, minus 12x. Okay, minus 12x. Greater than or equal to, okay, ax squared minus x cubed. Okay, this is inequality because it's greater than or equal. Okay, this is a 4th degree. So your first step, okay, okay, this is your first step you have to do. First step, okay, bring every term to the left hand side. Okay, that's your first step you have to do. Second step, okay, put it in factor form. Into factoring form. Okay. What I mean over here on the second step, you have to find g-shape, you have to factor some way somehow so that it becomes a linear factor. So you have to, I need to clarify this a little bit, put it into linear factor form. Okay, linear factoring form. Okay. If you cannot put into linear factoring, at least you have to put into factoring form. Okay. Because if you cannot put in factoring form, you cannot solve it. Remember, you cannot solve it using the sign table. You can solve it using the graph, using calculator. But it still takes a lot of time, okay? It still takes this is the best method, okay? So, let's see how we're going to solve this. Solution. Okay. Bring everything to the left-hand side. You have x to the 4 plus x to the 3rd minus x to 8x squared minus 12x greater than 0. So, I'm not only bring everything to the left hand side, but I also reorder them. Okay, so I start from 4th degree, it goes down to 3rd degree, 2nd degree, and the final 0 degree, just a number. Okay. The second step, after I move everything to the left hand side, I have to factor them out. Okay. So how I'm gonna factor this? How should I factor this? You already learned how to factor algebraic expression. And when I say factor, I mean GCF considered as priority. Can we do GCF here? That's the first question. Okay, that's the first question. Can we do GCF here? Oh, absolutely. The answer is yes. Because all 4 terms here, they contain x values, so we can find GCF. I don't know, because you guys probably some of you never taken intermediate algebra with me, and When I teach intermediate, I always say that when you do factoring, GCF consider as priority. You have to consider the GCF first. So over here GCF, we have GCF. I take GCF out is x. So x to the third plus x squared minus 8x minus 12. So after you find GCF, it looks like this in factoring form already. It's linear. However, this is not. We want to see if this factorable or not. We try to factor as much as you can, okay? I mean, sometimes you cannot factor, that's fine. But if you can factor, you have to. So how are we going to factor this? Okay, so let's see. Remember, there's a way we learn. In intermediate, it's called grouping. Okay, let's see if we can group this or not. Okay. Sometimes if we cannot, we have to do something else. So let's see if we can group this and this. X plus 1. It doesn't work, right? Because if we group this, I take 4 out. You have 3. So it's not working by grouping. So what should we do now? What should we do? This is the third degree polynomial. And in order to factor third degree polynomial, okay, in order to factor this third degree polynomial, you guys have to take a guess of the solution of this polynomial. Okay, you have to take a guess. Okay. And the value you take for that guess will be a very simple value. Very simple value. For example, like 1, 2, 3, -1, -2, -3. Those values are the value you should start. Okay. And you start 1. Let's say you start 1. Let's turn out to be 0 or not. So 1 plus 1 is 1. 2 -8 is not. How about 2? 2 to the third, 8. 8 plus 4, 12. 12 minus 16. -4. -4, -12 doesn't work. So 2 doesn't work. How about 3? How about 3? How about 3? So let me do on the side over here, okay? So 3 squared, 3 to the third, plus 3 squared, minus 8 times 2, minus 8 times 3, minus 12. Let's see it turn out to be 0 or not. Because if it turn out to be 0, it means 0. It means 3 considered as the 0 of that polynomial. Okay? So 27, 9, 24 minus 12, 16, 36. Oh yeah, it is. It's 0. So it's 3. Oh, so 3 considered as 0. So the next factor must be x minus 3. Oh, x minus 3. But we need to find the rest of them. You need to find the rest of them. How are we going to find the rest of them? Let me erase that. How do we find the rest of them? That is just one factor. Remember the theorem we learned last time? The factor theorem we learned last time? Yeah. And the remainder theorem we learned last time? We're going to use that to factor. Remember? So if x minus 3 is the factor, then 3 is the 0. And we just checked that already. 3 is 0 because we plugged it in, it turned out to be 0. So if 3 is 0, we can set up the syntactic division, right? Right? So we 1, 3, 1, -8. Right? Now let's set up the syntactic division. We take all the coefficients. Okay? Okay. So if 3 is 0, it means our remainder at the end is 0. Okay. And whatever we have will be whatever the number we have in the front must be the coefficient of our quotient, which is the coefficient of our next factor. Okay, so now we factor this 1, 3, 4, 12, right? 4, 12, there you go, 0. Right, so our next factor will be x squared, right? Because this is to the third power, we take 1x, we have x squared plus 4x plus 4. Okay. So it will be over here, it will be x squared plus 4x plus 4 greater than 0. And x squared plus 4x plus 4 is actually x plus 2 squared. Okay. So you see that I successfully converted a polynomial into a linear factoring form. A linear factoring form. Okay, so after I do that, okay, I set up the side table. Okay, so what I'm going to put on this side table, I'm going to put on the 0 on that, so it will be the 0 will be negative 2, right? It will be 0, it will be 3. So we have 1, 2, 3, 4 interval. 1, 2, 3, 4. I'm going to pick the value. I'm going to pick the value in those intervals. I'm going to pick over here 4. I'm going to pick over here 2. I'm going to pick over here negative 1. Over here I'm going to pick a negative 3. Whatever value you want to pick, as long as in that interval. And you're going to plug into this to see it positive or negative. Okay? So I'm going to do it quick. Okay, I'm going to skip that step, and now we have over here positive, negative, positive, okay, and positive. So we will have positive, positive, negative, positive, okay. And what part we're going to take? Of course, because this is greater than or equal to 0, so we're going to take all the positive part, just this and this. Okay, so my final answer will be what? Negative infinity to 0. Okay, include 0 because it's equal sign. Union would include 3 because it's equal sign. Because if it is equal sign, so we have to put bracket 3 to infinity. So this is interval notation for the solution of this polynomial inequality. Okay, so remember that if it gives you the polynomial, it's not in linear factoring form. Your job is to bring into linear factoring form. If it gives you linear factoring form already, which is very easy. Okay, you just need to set up the table and put the value on that number line. But it's not, then you have to factor. Okay. So that is when you solve polynomial inequality. Another inequality, and the second part, the second Roman of this lecture, it is rational inequality. Rational inequality. What is rational inequality? It is just an inequality, but it's in fractional form. Okay, it is in fractional form. Again, you have to factor the, you have to put it into linear factoring form also in order to solve rational linear inequality. Because if it's not, then you cannot solve it. All right. I can give you a typical example of a rational inequality look like. For example, I have like this: x minus 1 over x plus 3. X minus 1 x plus 3 square greater than 0. This is rational inequality, and it's already been in linear factoring form, because you see this is factor x and another factor x minus 1 is in product form. X plus 3 square is x plus 3 times x plus 3. So this is a typical example of rational inequality, and we can solve this easily by using the table. So let's go ahead and solve it together. First of all, we need to know all the value you have to put on the number line. So we have negative infinity here, infinity here. So the first value will be 0, right? Because you set x equal to 0. Alright, so you set x equal to 0, you set x minus 1 equal to 0, and another thing, you set x plus 3 equal to 0, and you solve for the x value. So the first one is 0, the second one is 1, and the third one is negative 3, so negative 3 here, 0, and 1. And at negative 3 plus 3 is 0 here, so it's undefined, okay? So make sure that even though that you have greater than equal, you're supposed to use bracket for all the value, but I mean, at negative 3 is undefined, so you have to use parenthesis at negative 3. So we have 1, 2, 3, 4 interval, so you're going to plug in the value, so I'm going to plug in 2 here, plug in 0.5, 1.5, half over here. You plug in negative 1 here, negative 4 here, and after you plug it in, you see that this is turned out to be positive, negative, positive, and this is also positive. Okay, and we always want to take the one that's greater than or equal to 0. So we just take this part. Okay, and this part only, okay? So your final answer will be what? The final answer will be negative infinity. Usually negative infinity to 0 bracket, but the thing is, remember, at negative 3 is undefined, because negative 3 plus 3 is 0 at the denominator, so it's undefined, so you have to split it up. So negative 3, negative infinity to negative 3, union with, you see that you have to use the parenthesis at negative 3 because it's undefined there. You have negative 3 to 0 bracket, so I have to use 0, you have to use bracket for 0 because this is greater than or equal. Union with, bracket, 1 infinity, parenthesis. Okay, so that is the interval notation solution for this rational inequality. Okay, so again, if your rational inequality is not in factoring form, then you have to factor, but most of the time it's in factoring form already. Especially on the test or the assignment, I give you the one that's in factoring form. Maybe I give you one problem that is not in factoring form, then you have to factor, but most of them will be in factoring form. Okay. On the second example, I have something a little bit harder. Let me see. So I want you to solve something like this. Let me see. How about I have 4x minus 5 over x minus 2, okay, less than or equal to 3. Okay. So the question over here is not in factorial form, because you see that we still have number 3 on the right hand side. We must have 0 on the right hand side in order to set up the table, the side table. So what you have to do is you have to subtract both sides by 3. You have to subtract both sides by 3, so you have 4x minus 5, x minus 2, subtract by 3. Okay. Then you find least common denominator. So find least common denominator give you what? 4x minus 3, 5 minus 3, x minus 2 over x minus 2. Okay. Okay. So that's your first step you have to do. Okay, you have to bring everything to the left hand side. You cannot go ahead and multiply both sides by x minus 2. If you do like that, it will be wrong. Okay, you never do that when you solve rational inequality. You have to move everything to the left hand side and find least common denominator and try to factor. That's what you have to do. Okay, so you have 4x minus 5 minus plus 6 over x minus 2 less than or equal to 0, and this is give you x plus 1, x minus 2 less than or equal to 0. Alright, so you see that now it's in factoring form already, huh? You have two value, x plus 1 equals 0, x minus 2 equals 0. So you're going to put what value on the number line? You're going to put negative 1 on the number line, you're going to put 2 on the number line, because you solve for x over here, x equal 2, and you over here you have positive infinity, you have negative infinity, then you plug the value here. Okay, you plug the value. You can plug any value inside this interval. For example, you plug 3. You plug any value inside this interval. For example, you can plug 0, and over here you can plug negative 2. It doesn't matter what value you plug in. You plug into this, to here. Okay, you plug it in here. And after you plug in here, you see that this is turned out to be positive. It's negative and it's positive. And remember that you just take the one that's negative because it's less than or equal to 0. So you're gonna take this part only. Okay. And make sure you have to use bracket because this is equal sign. So your final answer will be what? Your final answer will be bracket negative 1, 2, bracket. Okay. Alright, so that is final solution for that rational inequality. So you see that if you have a number on the right hand side, you have to remove it. Okay, you never want to multiply both sides by a certain value. You need to move everything to the left hand side and find least common denominator. Okay. I can do another one, for example, like this. Let's see. So it has been more than a week since my first announcement, and I feel like some of you students, some of you just open the canvas and check the message. I don't know what you guys have been doing, you know, but you have to check your canvas message all the time, check all the announcement all the time, okay? Because you don't want to miss any announcement or any message, okay, or assignment. So please check the announcement all the time and make sure you watch all the video. So, example number 3. Have 1 over x minus 2. 1 over x minus 2. Less greater than or equal to 1 over x plus 3. Okay, again, you have to move everything to the left hand side so that you have 0 on the right hand side. So what you have to do, 1 over x minus 2 minus 1 over x plus 3. Then you find least common denominator. Okay, you multiply over here by x plus 3. And you multiply down here and up here, x minus 2. Then you distribute it, I give you cancel the x, right? 5 over x minus 2, x plus 3. And now you successfully convert it into factoring form. On the top you have 5, the bottom you have x minus 2, x plus 3 is in factoring form, but the top just in a number so you can ignore them. And you go ahead and solve for the x value so that you can put those value on the number line. So you have x equal 2, and over here you have x minus 3. And you put these two values on the number line. Negative infinity, negative 3, 2, positive infinity. And you can plug again, you have 3 intervals, you can plug any value inside of an interval. So I'm not doing that, that's your job. You go ahead and plug it in, and you will see that this is positive, negative, positive. And you just take the one that's positive, so you take this interval. Okay, and you take this interval. And make sure that the end point you have to use bracket because this is equal sign. Okay. So your answer will be negative infinity to negative 3 bracket. See that? Union with 2 positive infinity parenthesis. Okay. So that is your final answer for this rational inequality. Okay. Any other question? So remember, that's all you have to remember. That's all you have to remember. Move everything to the left hand side. Find least common denominator and factor. Okay, and factor. There's some problem. That's very trivial. For example, something like this. Sometimes you don't have to set up the sign table because it's very trivial. It's very obvious. You don't have. You just need to use your logic, the common sense. Okay. Example 4. For example, I have something like this: x squared x4 plus 2 greater than 0. Okay. So you see that this equation, this rational inequality here is pretty obvious, right? Because everything squared is positive, everything raised to the 4 also positive. Add another number is positive, so a positive over another positive is a positive number. Of course, this is greater than or equal to 0. Of course, it's greater than or equal to 0. Alright? Then, if you see something like this, you can get the solution will be negative infinity to positive infinity. Okay? Because it's common sense. No matter what value inside this interval, okay, you plug in here, it's always greater than 0. Okay, it's always greater than 0. So the answer is it's pretty obvious. The answer will be a negative infinity to positive infinity. You know, this interval also includes 0 because even you plug 0 here, 0 over 0 plus 2, right? 0 plus 2 is 2, so 0 over 2 is just 0. So it's still satisfied this. It's still satisfied the condition is greater than or equal to 0. Okay, then you don't have to